This chart shows human transportation mass is 40 times greater than all wild land animals combined. Because this massive ecological wake blankets our planet, we assume any other intelligent species must be equally loud, mechanized, and disruptive to their environment. But consider a species that never developed combustion engines or global shipping lines. If an intelligent species lives in an isolated niche deep underground or hidden deep within the unobserved ocean, their ecological movement metric would register as exactly 0 on our surface monitors. Our failure to detect other advanced life forms on Earth might simply stem from the fact that we are only searching for our own destructive reflection. The true scale of our blind spot is massive. The deep ocean, defined as regions plunging below 200 meters, makes up more than 90%, but sonar only captures the physical contours of the terrain. It completely misses the biological data necessary to spot localized ecosystems. This spatial comparison chart highlights the true gap in our knowledge. While the sonar coverage is vast, direct visual observation, the only guaranteed way to confirm complex life, has covered less than 0.001% of the deep sea floor. That is an area the size of Rhode Island. That leaves 99.999% of this massive underwater domain entirely unseen by human eyes. It is an unobserved vacuum, giving us the mathematical space to run the probabilities on what might actually live inside it. The highest probability tier requires no speculation. Non-human intelligence, with complex social rituals and linguistic structures, is already a documented fact on Earth. The cultures built by cetaceans, like whales and dolphins, demonstrate that high-level cognition is a convergent biological trait. It evolves naturally across entirely different branches of the tree of life, rather than being an anomaly exclusive to hominids. We see this across invertebrate lineages as well. Cephalopods, such as octopuses, display advanced problem-solving capabilities and intricate behaviors entirely without the need to mine metals or construct a technological footprint. Biological intelligence thrives here, independent of tool building or a terrestrial habitat. Moving down to a moderate probability, we pivot from the known oceans downward into the unexplored terrestrial crust and isolated deep Earth aquifers. This brings us to the ophiol biome hypothesis. An ophiol biome refers to vast, isolated underground ecosystems capable of hosting complex, multicellular life in the dark. We have only begun to survey these deep Earth habitats. The historical assumption was that deep life lacked the energy to sustain itself without sunlight. But researchers have discovered high-energy chemosynthetic oases, environments where organisms extract energy from chemical reactions, like hydrothermal vents, which bypasses that barrier entirely. Because the thermodynamic limits for biology are far broader than we once thought, the existence of isolated, highly evolved subterranean entities is metabolically viable. Lower on the probability scale is a concept known as the Silurian hypothesis. This is a thought experiment asking whether a pre-human industrial civilization could have existed millions of years ago. This diagram of geological rock strata illustrates why that is highly unlikely. Any industrial civilization would leave permanent geochemical traces in the rock record, such as sudden carbon spikes, microplastic layers, or concentrated nuclear waste. We have never found those markers. Beyond these physical searches lies a purely theoretical possibility, the existence of a shadow biosphere, consisting of organisms that utilize entirely alternative biochemistry. Our current scientific instruments and genomic tools are exclusively calibrated to detect carbon-based, DNA-driven biology. If a life form operates on a completely different chemical foundation, it could be thriving right in front of us without triggering a single sensor. The search for alien intelligence might not require interstellar travel. It may just require a different set of microscopic lenses to see what is already here. Our ongoing search for sapience is compromised by anthropocentric bias. We continually demand that non-human life behave, build, and communicate exactly like humans. A highly cognitive species, perfectly adapted to the crushing pressures of the Hadal trenches, the absolute deepest parts of the ocean floor, or the deep terrestrial crust, would possess an ecological footprint of absolute 0 from our vantage point. To find definitive answers, we have to rethink our methods. We need to look beyond standard genomic sequencing and initiate massive, direct visual surveys of the deep sea. Until humanity physically crosses that 99.999% exploration gap, Earth is not a fully conquered domain. It is a massive, silent planet of undiscovered strangers.